Welcome to the Massive Loop tutorial series. I'm Tim, and in this tutorial, I'll be showing you how to use C# to create custom mechanics in Unity for Massive Loop. Massive Loop is a highly powerful platform for Unity developers looking to create metaverse or spatial computing experiences. It enables you to apply your Unity skills while providing a suite of essential tools such as hosting, multiplayer functionality, cloud persistent variables, and avatar toolkits. These features are available across VR, desktop, and WebGL platforms, making it versatile for various development needs. Massive Loop is trusted by universities, businesses, and Unity game developers alike. The mechanics we'll be creating are inspired by one of my favorite childhood animes, Dragon Ball Z. In Dragon Ball Z, the characters fly around the world and shoot energy beams out of their hands. Today, we'll be bringing one of those exciting concepts into the world of VR. You'll learn how to implement a flight mechanic that lets players soar through the virtual skies, giving them the freedom to move around the environment with the same agility and speed as their favorite characters. Now with that being said, let's get right into the tutorial. I already have an environment set up for testing our flight mechanic. This is Aether City. It's a city set in space with a gorgeous planetary view as a background. You're more than welcome to use any environment that you prefer. To begin, let's create an empty game object and name it Player Controller. Then create a C# script and name it Player Controller as well. Select the Player Controller game object and add the Player Controller script, which we just created. Next, let's open up our Player Controller script and start the scripting process. The first thing we need to do in our Player Controller script is make it a singleton. If you're not familiar with singletons, they're incredibly useful for ensuring that only one instance of a class is accessible throughout your project. This way, you won't need to reference the player controller directly in every script that needs it. Instead, you'll just call the instance and Unity will handle the rest. To do this, start by creating a private static instance variable inside your player controller class. This variable will store the single instance of the class that we'll be using. Next, we'll create a public static property to access this instance. Here's the key part. In the getter of this property, we'll check if the instance is null. If it is, we'll log an error message. This serves as a reminder to make sure our player controller exists in the scene so we don't run into any nasty null reference errors later on. Now that we have our instance variable and property set up, we need to ensure that the singleton pattern works as intended. This means making sure that only one instance of player controller exists at any time. We'll do this in the awake method. In the awake method, the first thing we need to do is check if the instance is null. If it is, that means this is the first and only instance of the player controller, so we set the instance to this object. If another instance already exists, we want to destroy this one so we don't accidentally end up with two player controller instances floating around in our scene. Next, let's create two variables. One ML player variable named local player and a game object variable named flight object prefab. The ML player variable will serve as a reference to the local player. The flight object prefab variable, which is of type game object and is marked with the serialized field attribute, meaning it will be exposed in the Unity inspector even though it's private. This prefab represents the object that will be used to control the flight mechanic in our world. We'll create the actual prefab for this reference after finishing this script. With our variables ready and our singleton pattern in place, it's time to move on to the start method. We'll use the start method to kick off the initialization process for our player. We'll do this by calling a coroutine. We want to delay the player initialization by a few seconds to make sure the scene is fully loaded before we try to access the player object. This helps avoid any potential timing issues where the player might not be ready to go when our script runs. In the coroutine, we'll use wait for seconds to introduce a short delay. This gives Unity some breathing room to fully load all the necessary objects in the scene, including our player. After the delay, we'll retrieve the local player using massiveloop_room.getLocalPlayer. Once we have our player reference, we need to attach the flight object to the player's hands. This is where the flight object prefab comes into play. We'll instantiate this prefab at runtime and then attach it to the correct hand transform on the player. To do this, we'll use a custom method called findTarget. This method will search through the player's hierarchy to find the correct hand transform by name, and then attach the object accordingly. Let's talk a bit about the findTarget method. This method is recursive, meaning it will search through the entire hierarchy of the player object until it finds the specific transform we're looking for, whether that's the right hand, left hand, or even the camera. When the method finds the transform that matches the name we provided, it attaches the corresponding object to the transform. It also aligns the object's position and rotation so that it sits perfectly in the player's hand or head, depending on where we want it. This is crucial for VR as it ensures that objects, like the flight object, are perfectly aligned with the player's movements. That's all we need for the player controller script. Now let's head back to the editor and create the flight mechanic prefab and scripts. In the editor, create an empty game object in the scene and call it flight object. Then add a rigid body and a sphere collider to the object. For the sphere collider, make sure the isTrigger checkmark is checked. This way, the collider doesn't interact with the player, and set the radius to 0.1. On the rigid body, uncheck the Use Gravity checkbox and check the Is Kinematic checkbox. Next, let's add an MLGrab component. On the MLGrab component, change the grab mechanic to custom. This allows us to create a custom script for the grab component. Lastly, check the stick to hand property, and what this does is whenever the player grabs the object, it sticks the object to the player's hands even after the grab button has been released. Now let's create a new C# script and call it flight. Go ahead and add the flight script to the flight object in the scene. The script is going to handle everything related to the player's flight mechanic, from launching into the air to hovering and flying forward. Once you've created the script, open it up and let's get scripting. At the top of the script, we'll import the ml.sdk namespace, which will allow us to use the MLGrab component. This component will handle detecting when the player grabs the flight object. Now let's start by declaring some variables that will control how our flight mechanic behaves. We'll add these right after the class declaration. First, we need to reference the MLGrab component. This will allow us to detect when the player grabs or releases the flight object. We'll declare this as a public variable so we can easily assign it in the Unity inspector. Next, let's add a few serialized fields that will let us fine-tune the flight behavior directly from the inspector. For instance, we have launch speed, which controls how fast the player launches upward. Then there's hover amplitude and hover frequency. These will define how the player hovers once they're airborne. We also need flight speed, which sets how fast the player moves forward during flight. We'll also include required hover height, which is the minimum height the player needs to reach before hovering kicks in. And finally, stopping distance, which ensures the player stops flying when they're too close to an obstacle. To manage the state of the player during flight, we'll declare a few Boolean flags. These will help us track whether the player is currently grabbing the flight object in flight mode or actively flying. Is grabbed will be true when the player grabs the flight object. Is in flight mode will be true once the player reaches the hover height and can start flying. Is flying will be true when the player is actually moving forward during flight. We'll also declare some references for the player's rigid body and transform, as well as a couple of coroutines to handle hovering and launching. We'll need to store the player's initial gravity setting so we can restore it later. In the start method, we'll set up our listeners for the grab event. This will call specific methods when the player starts or stops grabbing the flight object, and when the player presses or releases the trigger button. We'll also grab references to the player's transform and rigid body through the flight controller singleton instance we created earlier. We need to save the player's initial gravity setting at the start. This allows us to reset it later, ensuring that the player's gravity behaves normally after they stop flying. Now let's create a method called onGrab. This will handle what happens when the player grabs the flight object. First, we'll set isGrabbed to true and disable gravity. This makes sure the player doesn't fall while they're getting ready to fly. We'll also reset the player's velocity to 0 to stop any existing momentum. This is key for a smooth launch into the air. Finally, we'll start a coroutine called Launch Player Upward. This coroutine will smoothly move the player to the required hover height before enabling flight mode. The Launch Player Upward coroutine is where the player gets lifted into the air. We'll use a raycast to check how far the player is from the ground. If they're below the required hover height, we'll move them upward until they reach that height. Once they're high enough, we'll switch to flight mode by setting the is in flight mode to true and start the hovering process. Hovering is handled by another coroutine, Hover Player. This coroutine will continuously adjust the player's height to create a smooth up and down motion, simulating hovering. We use mathf.sine to apply a sine wave, which gives the nice oscillating effect. This coroutine runs as long as the player is in flight mode, but not actively flying. To handle forward flight, we'll create a method called onTriggerDown. This method will be triggered when the player presses the trigger. If the player is in flight mode, we'll set isFlying to true and stop the hover coroutine to switch from hovering to flying. In the update method, we'll check if isFlying is true. If it is, we'll cast a ray forward to detect any obstacles. If an obstacle is too close, we'll stop the flight. Otherwise, we'll move the player forward in the direction the flight object is pointing. When the player releases the flight object or the trigger, we'll need to stop all actions and reset the player's state. We'll handle this in the onGrabEnd and onTriggerUp methods. In onGrabEnd, we'll set isGrab to false, stop all active coroutines, and restore the player's gravity to its initial value. In onTriggerUp, if the player is still in flight mode but no longer flying, we'll restart the hover coroutine to resume hovering. The stop all actions method will ensure that all flight-related actions stop immediately, preventing any unintended behavior. And finally, we'll use a reset player state method to clean up and reset flags, preparing the player for the next time they want to fly. Now that the flight script is done, let's return to the editor and set up all our references and values. On the flight object, first drag the MLGrab attached to it to the grab field on the flight script. Set the launch speed to 5, hover amplitude to 0.5, hover frequency to 2, flight speed to 70, required hover height to 5, and stopping distance to 1.5. These values ensure the player has a smooth flight experience with little to no chance of inducing motion sickness. Next, create a prefab of the flight object by dragging it into the asset folder. Once you have your prefab, drag it from the asset folder to the flight object prefab field on the player controller. Now you can delete the flight object from the scene, as a new one will be instantiated during runtime. Now that we have everything set up, let's test our flight mechanic in the testing environment. Great, it looks like the flight object has been properly instantiated in the player's left hand position. And when I press the grab button on the controller, it initiates the hover sequence and then puts me in flight mode. Now when I press the trigger, I can fly in whatever direction my left hand is pointed, and if I fly too close to an object with a collider, the flight is stopped. That about wraps it up for the flight mechanic in this tutorial series. Keep an eye out for the next tutorial, which will cover how to shoot an energy beam out of the player's hands, just like in Dragon Ball Z. Thank you guys for watching, and I'll see you on the next one.